All right, let's jump right into the ultimate cosmic detective story, hunting for a hidden fifth force of nature. If you're as obsessed with the universe's unsolved mysteries as I am, you are going to absolutely love this explainer. We're tracking down a suspect that literally makes up the vast majority of our universe, but somehow it's totally evaded every single local trap we've set for it.
So to get started, we have to ask a massive, kinda uncomfortable question. What if Einstein was only half right? I know, it sounds like total scientific heresy. For over a century, relativity has been the absolute gold standard playbook of physics. But as our telescopes get sharper and we peer farther out, we're starting to see some undeniable cracks in that foundation.
And that brings us to the Great Disconnect, which is, at its core, a complete crisis of scale.
Let's just put this crisis into perspective. Look at this breakdown. A mind-blowing 95% of our universe is made up of this invisible dark sector. We're talking 68% dark energy pulling the cosmos apart, and 27% dark matter holding galaxies together. That means everything we can actually see, touch, and measure, stars, planets, the device you're on right now, fits into a measly 5% slice. 5%.
Now, here's where it gets truly weird. Out in the deep universe, physics is playing by a completely different set of rules. On a cosmic scale, we absolutely have to factor in dark energy or modified gravity just to make the math work for spinning galaxies and accelerated expansion. But locally, right here in our solar system, Einstein's math is basically flawless. The planets orbit exactly as they should. We see zero dark energy, zero dark matter, nothing.
This totally bizarre mismatch is what drove scientists to desperately look for a local fifth force to bridge that gap. And that leads us to a pretty infamous past suspect, the Pioneer anomaly. It's the perfect example of why this hunt is so incredibly tricky.
Picture this, it's the 1980s, and NASA notices the Pioneer 10 and 11 probes are mysteriously slowing down as they leave the solar system. And not by a lot. We're talking about an unbelievably tiny deceleration of 8.74 times 10 to the negative 10th meters per second squared. It was just this microscopic drag pulling them back toward the sun, but it was absolutely there. For a while, everybody thought, yes, we found it, the fifth force.
But science takes time, right? Unraveling this took literally decades, from the 70s launches to finding the glitch in the 80s, all the way to 2012. It took a massive effort to recover 43 gigabytes of ancient punch card and magnetic tape data before NASA's Dr. Slava Turyshev finally cracked the case.
And the verdict? Actually, scratch that fifth force idea. It wasn't a new force at all. After years of number crunching, Dr. Turyshev's team proved it was just thermal recoil. The spacecraft's own internal electronics and nuclear batteries were giving off heat, and that heat was bouncing off the antenna dish like tiny photon headlights, literally pushing the probes backward. Standard physics won that round.
So naturally, you gotta wonder, if our best lead turned out to be just spacecraft exhaust heat, is this fifth force even real? Are we just chasing shadows in the data here? Well, according to some really cutting-edge new research, the force is absolutely real. It's just a master of disguise.
Let's define exactly what we're hunting for. We're talking about a fifth force, a brand new, fundamental interaction, completely separate from gravity, electromagnetism, and the strong and weak nuclear forces. It's the hidden hand governing that giant 95% dark sector while staying perfectly invisible to our local probes.
So how does it hide? Well, in a 2026 paper, Dr. Turyshev lays out the math for something called screening mechanisms. These are wild theoretical processes that let the force literally adapt its physical properties. It changes its strength or its range depending on the density or gravity of its environment. It's practically camouflaging itself.
We've got two main theories on how it pulls this off. First is the Chameleon Mechanism, which, true to its name, adapts. In high-density places, like our solar system, its range shrinks down so much it only exists in paper-thin shells around objects. The second suspect is the Weinstein mechanism, where the intense gravity of a massive object basically paralyzes the force completely.
And if the Weinstein mechanism is right, the numbers are just staggering. Our sun is basically acting as a gigantic gravitational shield. Its Weinstein radius, meaning the zone where this fifth force is totally shut down, is estimated at 400 light-years. That means we, and countless neighboring stars, are sitting completely trapped inside this colossal suppression bubble. No wonder we haven't seen it.
But physicists aren't giving up that easily. If we can't find it out in space because of this giant bubble, we need to zoom all the way in. We're talking about looking for microscopic cracks in the shield at the absolute smallest scales imaginable, the subatomic level.
And guess what? They found something huge. At ETH Zurich, researchers were using super-precise lasers to measure energy shifts in calcium isotopes. And they found a deviation from the standard model of physics at a 1,000 sigma significance level. Now for context, a 5 sigma result usually gets you a ticket to Stockholm for a Nobel Prize. 1,000 sigma? That's practically a neon sign inside the atomic nucleus flashing new physics here.
The prime suspect behind this crazy atomic shift is the X17 particle. It's an insanely light boson, just 17 mega-electron volts. But the kicker is that it's protophobic. It'll interact with electrons and neutrons, but it completely ghosts protons, which perfectly explains why we've missed it in normal proton-heavy environments. X17 might literally be the portal connecting our measly 5% universe to the entire dark sector.
And while all that's happening in the lab, astronomers are using near-Earth asteroids as giant, high-precision test weights. Data from the Bennu asteroid has already helped narrow things down. But the main event is Apophis. In 2029, Apophis is going to buzz by Earth within 20,000 miles. The hope is that the insane gravitational tidal stress of that flyby might actually break the screening mechanism for just a second, amplifying the hidden force enough for us to finally catch it on tape.
Now, knowing that we're stuck inside this massive suppression bubble means standard solar system tests just aren't going to cut it anymore. We have to design missions specifically to pierce this shield. We need a cosmic sting operation.
So here's the plan for the ultimate sting, the Solar Gravitational Lens, or SGL, mission. The idea is to fly a probe a mind-numbing 650 astronomical units straight away from the Sun. Why so far? Because that is the absolute edge of the Sun's gravitational dominance. It's where the Vansteen shielding finally drops off, letting us measure if gravity actually starts to shift. We're attacking this from every angle, though. There are proposals for tetrahedral spacecraft flying in formation to map local space-time with lasers. And right here on Earth, there's the tabletop Morris experiment, using magnetically levitated magnets to hunt for weird, non-Newtonian gravity at the millimeter scale.
So what does this all mean? Catching this fifth force isn't just about bagging another particle for the textbooks. If we prove this, it could trigger a radiative waterfall, a massive cascade of breakthroughs that could finally unite Einstein's gravity with the super weird world of quantum mechanics into one unified theory of reality.
There's a quote from the research that I just love because it hits the nail on the head regarding where we are right now. It says, "The universe's biggest secret is no longer just a theoretical whisper. It is a measurable phenomenon waiting for the right instrument to see it."
Which leaves us with one incredibly wild thought to wrap up this explainer. If this fifth force is real, and this giant shield is just masking it from us, where is the dark sector hiding around you right now? Is it hovering in the empty space between the atoms and the very screen you're looking at? It is an absolutely fascinating mystery. And the real detective work, it's just getting started. Keep your eyes on the stars, folks, and the subatomic particles.